Researchers and inventors at the University of Colorado Boulder are developing breakthrough technologies and discoveries with the potential to shape the future and improve lives. This series of articles from venture partners at CU Boulder explores the people and ideas driving that work forward. In each episode, we share stories from the university's innovation ecosystem, following the path from research and discovery to startups, partnerships, and real-world impact. From quantum to biotech and beyond, these stories offer a closer look at how innovation moves beyond the laboratory and into the world. Today, we present A Powerhouse and Battery Breakthroughs by Heather Hansen. The University of Colorado Boulder is at the cutting edge of battery technology, from groundbreaking research to billion-dollar ventures. Tyler Evans is an alum of CU Boulder's Paul M. Rady Mechanical Engineering Department and Materials Science and Engineering program. When Evans was applying to PhD programs, he knew he wanted to focus on batteries. I remember having this impression that batteries were literally a way to bottle up energy and put it in your pocket and use it to do what you wanted anytime you wanted, and that feels a lot like a superpower, Evans said. That was the start of an exciting era in energy storage, and the race was on to build a better battery that lasted longer, was safer, and less expensive. At the time, there were just a handful of universities, including CU Boulder, working on that kind of technology. And Evans was interested in working specifically with CU Boulder mechanical engineering professor Sehi Lee, a pioneer in solid-state battery technology who had joined CU Boulder from the National Renewable Energy Laboratory, now the National Laboratory of the Rockies, several years earlier. Evans felt an immediate affinity with Lee's research objectives and lab culture and wanted to join his team. "Because I knew I wanted to study energy storage and new battery technologies," Evans said, "the support I found was instrumental in setting me up not just to be a good battery scientist and technologist, but also to look at the world through the lens of application and understand what could be useful for the world." Soon, Evans was part of the team generating test data that led to grant funding for Solid Power, a company spun out of the university by Lee and fellow CU Boulder mechanical engineering professor Conrad Stolt. At the time, Evans was crossing paths with Doug Campbell, Solid Power's then CEO and co-founder and a deep tech startup veteran, and Josh Buettner-Garrett, the company's CTO. Through those interactions, Evans was learning about the commercialization path for university lab innovations. "It felt exciting to be a part of that, to see your work have a pretty immediate and direct impact on a company that was hopefully going to make a real impact in the world," Evans said. Since then, Solid Power has become an industry-leading developer of next-generation, all-solid-state battery technology. The company went public in 2021 with major partnership deals with BMW, Ford, and Samsung SDI, and now has a 75,000 square foot manufacturing facility in Thornton, Colorado. As a company co-founder, Lee is excited to see Solid Power at the forefront of this technology, and he's equally gratified that the company has hired many past CU Boulder undergraduate, master's, and PhD students. "Creating so much opportunity for the young generation, that's kind of the most exciting stuff," said Lee. Lee was also the principal investigator guiding the team that led to the spin-out of another company, this one co-founded by Evans and fellow student Daniela Molina-Piper, also a CU Boulder mechanical engineering alum. That venture was called Cilion, which focused on developing high-energy, non-flammable lithium-ion systems for solid-state batteries. Evans saw a new lithium-ion cell technology through prototyping and early pilot demonstrations until 2018, when the company was acquired by Tesla. According to Bryn Reese, Senior Associate Vice Chancellor for Innovation and Partnerships at CU Boulder, Solid Power and Cilion put CU Boulder on the map for battery technologies, giving the outside world a sense of the high caliber of research coming out of the university. Soon thereafter, in 2020, Michael Marshak, a then CU Boulder assistant professor of chemistry, founded eToro Energy to commercialize a breakthrough flow battery, a rechargeable battery in which electrolyte flows through one or more electrochemical cells from one or more tanks. The company's patented low-cost electrolyte, licensed from CU Boulder, uses abundant and non-critical materials, is water-based, non-corrosive, non-flammable, and non-toxic. "We've had this incredible productivity in battery innovation at CU. It's a unique strength that we've got here," said Reese. Other prolific university labs have contributed to advancing battery technologies in unexpected and intriguing ways. Take the lab of Professor Al Weimer in CU Boulder's Chemical and Biological Engineering Department, where students work at the forefront of innovation in atomic layer deposition, nanocoating technology. That's the process of putting down ultra-thin coatings on particles and plastics to improve the performance of new and existing products, including batteries. Researchers on Weimer's team have shown that with lithium-ion batteries, ALD can improve performance, extend life cycle, and enhance safety in consumer electronics like laptops, cell phones, and electric vehicles. Weimer co-invented the core ALD technology that formed the foundation for an early spin-out called ALD Nano Solutions, which merged with Forge Nano in 2021. Forge Nano was co-founded by Paul Lichty, an alum of CU Boulder Mechanical Engineering and Chemical and Biological Engineering departments, and Dave King, a CU Boulder postdoctoral research assistant, both formerly part of Weimer's team. Lichty, now Forge Nano's CEO, developed and patented an idea for scaling up the ALD process, and the company now uses the technology to make scalable nano coatings for various applications, including batteries, semiconductors, and more. Forge Nano's proprietary ALD formulation, called Atomic Armor, makes battery electrodes better at storing energy. It's difficult to think of anything else I could have done that would have as big an impact as this company, Lichty has said. CU Boulder researchers like Lee, Lichty, and Evans have distinguished themselves by taking on the tough challenges inherent in advancing batteries and storage tech, and successfully pushing those innovations out into the world in an unprecedented and meaningful way. The notion in the field was that battery technology is too hard, and it's too hard for these companies to successfully raise capital, it's too hard for them to get partnerships and to commercialize, said Rees. Yet, what we've seen at CU Boulder has totally turned that thinking upside down. These really great research capabilities have translated into super impactful ventures, Rees finished. Several factors make CU Boulder a powerhouse for battery innovation, according to Evans. The Front Range and CU Boulder have a unique confluence of ingredients that have contributed to our strong track record of battery technology companies in the last decade or so, Evans said. First, he continues, the network of universities, national laboratories, and entrepreneurial resources provides a pool of world-class people and creates fertile grounds for breakthroughs. Second, the representation of major players in the energy industry and industries that use battery technology creates pull for new technologies with a focus on building commercial value. And finally, situated at the foot of the Rocky Mountains, the people here have a very direct connection to the environment. We're intimately linked to the impact of our work, Evans finishes. Evans is now CEO and co-founder of Mana Battery, a 2023 spinout from the lab of Professor Chunmei Ban of CU Boulder Mechanical Engineering. Ban, company co-founder and leading researcher in batteries and battery materials, focuses on next-generation electrochemical materials, specifically sodium and magnesium, to meet the need to improve renewable energy storage systems. Mana Batteries is advancing that groundbreaking work by developing sodium-ion batteries that are cheaper, safer, and longer-lasting than standard lithium-ion ones. At a CU Boulder-hosted conference on batteries and storage technology in 2024, Ban commented, "The U.S. has one of the largest sources of soda ash. The reserve is huge, so we have the resources to do something, and I feel it's the right time." She continued, "We feel confident about our technology. A gigantic market for batteries is already here, and I have a great team." At the same meetings, Evans expressed gratitude at being part of the ecosystem of great battery scientists at the university. CU Boulder has a really impressive track record in the battery space, and Mana is sitting in a place to enable a sodium-ion battery transition. They do everything lithium-ion can do at half the cost, which the grid needs, he said. Batteries, Evans finished, have the power to change the world. Thank you for listening to this article from Venture Partners at CU Boulder. To learn more about the featured researchers, startups, and innovations, and to explore how CU Boulder is translating discovery into impact, visit colorado.edu/venture partners. If you enjoyed this article, subscribe, share it with your network, and join us again for more stories from the people building the future through research, innovation, and entrepreneurship. Until next time, thank you for listening.